Welcome to Grade 5 Math, Chapter 2.2, Multiplying by Tens, Hundreds, or Thousands. We'll be exploring three main concepts in this chapter. The first is multiplying by 10, 100, or 1000 using patterns. Next, we'll multiply numbers up to 4 digits by multiples of 10, 100, or 1000, and finally, we'll use our knowledge of rounding from the last chapter to estimate products. Let's get started. Let's start by looking for a pattern in products when 10 is one of our factors. Just as a quick reminder, a factor is one of the numbers contained within the multiplication problem. So in 7 times 10, 7 and 10 are our factors. So let's review what 7 times 10 really means. 7 times 10 simply means that we have 7 tens, which equals 70. 10, 20, 30, 40, 50, 60, 70. If we look at 9 times 10, that means we have 9 tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, for an answer of 90. Now, if we look at 10 tens, that means we have 10 tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, to give us an answer of 100. Are you noticing a pattern yet? Let's examine these same multiplication problems using a place value chart. We'll represent 7 with 7 chips in the one place. 7 times 10 gives us a value of 70, or 7 tens, which we'll represent with 7 chips in the tens column. Now let's look at 9. We'll represent 9 with 9 chips in the one column. Now, if we take 9 times 10, or 9 tens, we get an answer of 90, or 9 chips in the tens column. Finally, let's look at 10. 10 can be represented with 10 chips in the ones column, and 10 tens, or 10 times 10, would be 100, or 10 chips in the tens column. Are you seeing the pattern? When we multiply a digit by 10, it simply moves one place value to the left. So 7 becomes 70 by moving one place value to the left. 9 becomes 90 by moving one place value to the left, and 10 becomes 100 by moving one place value to the left. I think of this as the case of the line cutting 0. Our friend 7 is quite happily sitting in the ones place at the front of the line until he's multiplied by 10. Then that bossy 0 comes in and shoves him over into the tens place so the 0 can be at the front of the line. Rude, I know. Let's see if our pattern of adding 1 0 holds for larger numbers. Let's take a look at the number 231. If we put those values in our place value chart, we'll have 2 hundreds, 3 tens, and 1 1. So let's multiply by 10, which is going to force a 0 into our ones column, moving our 1 to the tens place, our 3 to the hundreds place, and our 2 to the thousands place, giving us an answer of 2,310. All right, now let's mark 2,345. So let's multiply by 10. Again, that cutting 0 is going to push to the front of the line and put itself in the ones place, moving the 5 to the tens column, the 4 to the hundreds, the 3 to the thousands, and the 2 to the 10,000s, giving us an answer of 23,450. Let's look at our final example. 4,108. Oops, there we go. Times 10, here comes that bossy cutting 0 again. It's going to force its way into the ones column, moving our 8 to the tens place, our 0 to the hundreds, our 1 to the thousands, and our 4 to the 10,000s, giving us an answer of 41,080. Yup, the pattern still works. So the general rule we can always apply when multiplying a whole number by 10 is, to multiply a whole number by 10, just add a 0 after it. Very simple. Try these sample problems on your own. Please record these in your homework notebook. Now that we can see how simple it is to multiply by 10, let's use a trick to help us multiply by multiples of 10. Let's use what we know about multiplying by 10 to multiply 6 by 20. 6 times 20 is the same as 6 sets of 20. However, we also know that each 20 is made out of 2 tens. So we could also think of this problem as 6 sets of 2 tens. This helps us break the problem down into an even more simple problem. Now we can take 6 times 2, get an answer of 12, and then multiply that answer by 10, which we know, multiplying by 10, we simply add a 0 after the number, giving us an answer of 120. Multiplying 6 by 20 is the same as multiplying 6 by 2 and then by 10. You'll get the same answer. Let's try another example. 27 times 30. We can think of 30 as being equivalent to 3 tens, or 3 times 10. So we can take 27 times 3 times 10. 27 times 3 is 81 times 10 will give us an answer of 810. Multiplying 27 times 30 is the same as multiplying 27 times 3 times 10. Try these 3 multiple of 10 problems on your own. Please record these in your homework notebook. Also, please remember, if this is difficult to read, make sure you're watching in full screen mode. We've explored tens as a factor. What if 100 is our factor? Let's solve 5 times 100. This means that we have 5 sets of 100 objects. So we have 100, 200, 300, 400, 500 for an answer of 500. What if we have 11 sets of 100? 11 times 100. This gives us a value of 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100 for a product of 1,100. I bet you're seeing the pattern already. Let's try a product of 1,000. What if we have a problem that is 5 times 1,000? That means we're going to have 5 equal sets of 1,000. Or 1,000, 2,000, 3,000, 4,000, 5,000. So our product is 5,000. If we have 11 times 1,000, that means we have 11 equal sets of 1,000, which add up to 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000 for a product of 11,000. Once again, I bet you can already see that pattern. We have another case of the cutting zeros striking again. Our friend 5 is sitting happily in the ones column until he's multiplied by 100. And now not 1, but 2 zeros are going to force their way in. The first 0 will force its way into the ones column, pushing 5 over to the tens, and the second 0 will force its way in to the ones, pushing the first 0 to the tens and moving our 5 to the hundreds. So the same thing happens to our poor friend 11. When we multiply 11 by 100, we have those 2 zeros that force their way into the tens and ones column, pushing 11 into the hundred and thousands column, giving us a final value of 1,100. What if we multiply by 1,000? 1,000, you'll recall, has 3 zeros. All right, so here's our friend 5. hanging out in the ones column at the head of the line, happy as can be, until we multiply by 1,000. And this time, not 1, not 2, but you guessed it, 3 zeros come in and force their way into the ones, tens, and hundreds column, making 5 go to the thousands column, giving us a result of 5,000. If our buddy 11 is hanging out with 1, 1 in the tens column and 1, 1 in the ones column, our 1,000 is going to come in and, you guessed it, force its way with 1 0 into the 1, 1 0 into the 10, 1 0 into the hundreds, pushing a 1 into the thousands and the 10,000s column, giving us an answer of 11,000. So what rules can we apply now that we've looked at these patterns? We know that if we multiply a whole number by 100, we're going to add 2 zeros after that number to get our product. If we multiply a number by 1,000, we will add 3 zeros after that number to get our product. Quite simple and straightforward. Now that we understand this rule, we can use this idea to multiply by multiples of 100 and 1,000 quite easily, just as we did with multiples of 10. Let's say we want to multiply 7 times 200. We know that this problem really means 7 equal sets of 200. However, we also know that we can divide each of those 200s into 2 100s. Just as we divided each 20 into 2 10s in earlier problems. So we can think about this problem in this way. We have 7 sets of 200 or 7 sets of 2 100s, which makes this problem much more simple to calculate. Now we have 7 times 2, giving us a value of 14, times 100. Our 100 rule says that any time we multiply by 100, we simply add 2 zeros after the number. Therefore, our answer is 1,400. In this problem, we can see that multiplying a number by 200 is exactly the same as multiplying it by 2 and 100. Let's try another problem like this. Let's take 67 times 5,000. Again, we know that this means 67 sets of 5,000, which I am not going to draw for you. That would take quite a long time. But we do know that we could also think of this as 67 times 5 sets of 1,000, right? Because we can think of 5,000 as 5 times 1,000. So let's solve this problem now. 67 times 5 will give us a product of 335 times 1,000. Our 1,000 rule tells us to simply add 3 zeros after our number, giving us a product of 335,000. In this example, we can see that multiplying a number by 5,000 is the same as multiplying it by 5 and then by 1,000. Please try these problems, which use multiples of 100 or 1,000, on your own. Record your answers in your homework notebook. Let's finish today's lesson with the last idea. That's rounding factors to estimate products. Let's estimate the product of 632 times 26. First, we'll round each number to its nearest tens or hundreds to solve the problem. We're going to round 632 to its nearest hundreds, or 600, and 26 to its nearest tens, or 30. Now we can break these numbers apart and use our rules of 10 or 100 to solve the problem. I'm going to rethink of this problem as 600 times 3 times 10. I'm going to move up here to keep our problem going, pardon me. So let's see, 6 times 3 is 18, and then I'll add my 2 zeros on to account for that 6 being in the hundreds place. So now I have 1,800 times 10. Our rule of 10 tells us to simply add a 0 after our original number. So we added our 0, giving us a product of 18,000. Here's another example. Let's estimate the product of 228 times 57. If we round 228 to its nearest hundredths, we get an answer of 200. Times 57 rounded to its nearest tens place would be 60. So I'm going to think of this problem as 200 times 6 tens. 200 times 6 is 1,200, and I know that because if I ignore the zeros and take 2 times 6, I get an answer of 12. Then I simply put them back on the end so that I don't forget about them. So we have 1,200 times 10. Our rule of 10 tells us to put that 0 on the end of our original number, giving us an answer of 12,000. We'll finish our lesson by rounding factors to the nearest 10 or 1,000 to estimate products. So in this problem, we are going to multiply 1,215 by 26. All right, so we'll round 1,215 to its nearest 1,000, which would be 1,000. And we'll round 26 to its nearest tens, which would be 30. Once again, we'll break these problems to make it a little easier to do the multiplication. So we'll take 1,000 times 3 times 10, because multiplying by 3 and then by 10 is the same as multiplying by 30. 3 times 1,000, if we follow our rule of 1,000, we simply take our 3 and add the 3 zeros on, and then we multiply by 10. By following our rule of 10, we know that we simply need to add that 0 after our original number, giving us a product of 30,000. Here's another example. Let's estimate the product of 1,238 and 56. 1,238 will round to 1,000 and 56 to 60. If we break this problem apart, we have 1,000 times 6 times 10, because multiplying by 60 and multiplying by 6 and then 10 gives us the same result. 6 times 1,000, following the 1,000 rule, means that we add 3 zeros after our 6. 6,000 times 10. Following our tens rule, we simply add another 0 after our 6,000, giving us a final answer of 60,000. So the estimated product of 1,238 times 56 is 60,000. Here are your final practice problems for today. Please round each number to the closest tens, hundreds, or thousands. Then multiply. Record your answers in your homework notebook. Thanks for your hard work today, and I'll see you in class tomorrow.